Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acidity of CH bonds in compounds flanked by electron withdrawing groups depends on the number and type of carbonyl ester groups stabilizing the resulting carbanion through resonance and induction. Compound A, ethyl 2-oxocyclohexane, 1,3 dicarboxylate or diethyl 2-oxocyclohexane, 1,3 dicarboxylate. The acidic proton is at the carbon flanked by one ketone and one ester, the C between the ketone and one ester, or alternatively at C2 between the two ester groups flanking the ketone. Looking at the structure, it is a cyclohexanone with ester groups at the two alpha carbons. The most acidic proton is the 1-alpha to both one ketone and one ester, a beta-ketoester type system. This gives stabilization by 1C is equal to O, ketone, and 1 ester. Compound B, cyclohexanone with two ester groups on the same alpha carbon, quaternary carbon bearing to co-2 and adjacent to ketone. The acidic proton would be on the carbon between the ketone and the gemdiest carbon, but actually the quaternary carbon has no H. The acidic proton must be at the other alpha position to the ketone, simple alpha to ketone only, or this compound's most acidic H is at the carbon between two esters on the other side. Since the gemdiest carbon is quaternary, no H, the acidic proton available is only alpha to the ketone on the other side, simple monoactivated. This makes B the least acidic. Compound C, ethyl 2,1,3-deoxycyclohexyl, i.e. 2-ethoxycarbonyl, cyclohexane 1,3 dione. The acidic proton at C2 is flanked by two ketone carbonyls and an ester group. 3 electron withdrawing groups stabilize the carbanion at C2. This gives the highest acidity, similar to diaminister systems. The enolate is stabilized by resonance with two ketones and one ester. Ranking. B. Acidic H activated only by one ketone, least acidic. A. Acidic H activated by one ketone plus one ester, moderate acidity, beta-ketoester type. C. Acidic H activated by two ketones plus one ester, most acidic, triple activation. Thus, BAC, increasing acidic strength. This corresponds to option C. Wait, the given answer is C, which corresponds to answer choice CBAC. Why other options fail? A. ABC, wrong, B should be least acidic, not A, B, ACB, wrong, B is least acidic. D. BCA, wrong, C should be most acidic due to triple carbonyl activation. Therefore, the correct answer is C. Therefore, the correct answer is option C.